Good evening, and welcome to SkepTalk, the monthly speaker series hosted by the Bay Area Skeptics. Before tonight's presentation, a few words about Bay Area Skeptics. As North America's oldest skeptical organization, we are dedicated to promoting critical thinking, logic, and rational thought. In the 1970s and 80s, scientists such as Carl Sagan and magicians such as James Randi established the scientific skepticism movement out of concern about the popular fondness for pseudoscience and the lack of public science literacy. Scientific skepticism embraces evidence-based civil discourse on health, education, consumer protection, and especially the investigation of extraordinary claims. Using the scientific method, we hope to promote skeptical inquiry to reduce irrational thinking in society. This talk is supported by Bay Area Skeptics members such as you. Please visit us at baskeptics.org or join us on Facebook, Twitter, and Meetup. Consider supporting us through convenient monthly donations via Patreon. Patrons receive premiums such as discounts and free t-shirts for our annual Skeptical Conference. But more importantly, members help us make the world just a little more reasonable and rational. And now, tonight's speaker.
Good evening. I'm Eugenie Scott. I'm president of Bay Area Skeptics. Our speaker tonight is Dr. Alex Filippenko, easy for you to say, professor of astronomy at UC Berkeley. He has had a distinguished research career that has been recognized by his peers by election to both the National Academies of Science and the American Academy of Arts and Sciences. His research has been in areas such as galaxies, supernovae, black holes, and the accelerating expanse of the universe. This research has resulted in numerous academic prizes, which I will not enumerate tonight. We do want to have time for the talk. He is also recognized as an outstanding teacher, having won the University of California, Berkeley's Teacher of the Year 9 times. Just reflect on that for a moment. That's a lot of teaching and a lot of recognition. As perhaps illustrated by his presence with us tonight, he has shown a great willingness to share his ideas on science with the public and has appeared in over 120 documentaries. Our friends here in the Bay Area Wonderfest awarded him the Carl Sagan Award for Science Popularization. So it's pretty clear, pretty easy to see why we would turn to him for a thoughtful reflection on the existence of extraterrestrials. And that is his subject tonight. So, Alex, so good to have you with us. Welcome to Bay Area Skeptics.
Okay, very good, very good. Here we go. So thank you very much. It's a pleasure to be here this evening. Let's get started here.
I think that's a great idea.
About extraterrestrial life. So, of course, this age-old question, is anybody out there? See that? A big-time story. How the discovery of 2 planets brings us closer to solving the most profound mystery in the cosmos. This was a headline from the mid-1990s. Of course, we now know of thousands of so-called exoplanets. And everyone would like to know, are these creatures out here? Yoda from Star Wars, E.T., the extraterrestrial, coffee-loving Nebels in Men in Black, right? These things are in movies all over the place. The Vogon species in the Hitchhiker's Guide to the Galaxy. Ugly, bad-tempered, bureaucratic, and callous. Interestingly, they're all usually vaguely or considerably humanoid in appearance. There are also lots of cartoons, right? The phenomenon is real. The evidence is everywhere. Right, aliens are visiting us. I'm talking about climate change, crackpot. And I made the mistake of saying, take me to your leader. There we go. Okay. Well, seriously, the discovery of indigenous life on at least one other moon or planet, even in our own solar system, would greatly support the hypothesis that at least simple life forms easily. Okay, right? If it's in the first place you look, then it's almost certainly everywhere. And certainly the easiest place to look would be our solar system. So we will start there. I would say, the jury is still out. Simple life, microbial or bacterial life is possible in our solar system, but we don't have any evidence for it yet. I would say that if there were complex life, trilobites or tigers or humans on other planets in our solar system, we would have known by now. But even for microbes and bacteria, there is not yet any convincing evidence. Mars is discussed a lot because it has water in the form of ice, and sometimes that ice even melts, and you see little streamlets going by down crater walls. The Mars Perseverance rover is looking for signs of life based on water. Here it is, collecting 10 or 12 or more test tubes full of soil from different locations. And the idea is that somewhere around 2030, there will be a return mission when these test tubes of material will be brought back to us, and biologists could analyze them for signs of life. There's even this Ingenuity helicopter, which is quite an amazing thing because Mars's atmosphere is only 0.5% to 1% of Earth's atmosphere. And so the thing has to go at something like 3,500 revolutions per minute. But regardless, it worked. All right. Well, so here's a little cartoon. Okay, my turn. And the JPL Ingenuity rover or helicopter. So going outside our own solar system, besides Mars, of course, there's some moons of Jupiter and Saturn that may or may not have microbial life, but Enceladus, Europa, they have icy, slushy water oceans underneath their icy surface, but we've not done any probes there. So let's look to exoplanets to increase the odds. Are there other planetary systems? Are any of them like our solar system? Well, we now know of lots of exoplanets, but we want ones that are in the so-called habitable zone, not so close to the star that they orbit that they're too hot for water to exist in the liquid state on or near the surface, not so far away from the star that they're too cold and all the water is frozen. We want them in the Goldilocks zone, just right. That would be a habitable world, at least for life as we know it. And again, I'm fully aware that moons around big planets can be tidally heated and can form slushy oceans underneath the icy core, the icy crust, as in Europa and Enceladus. But here we're just looking at planets in the habitable zone, that is a range of surface temperatures that's right for water to exist. And we could talk about silicon-based life or other such life, but we'll be more well-grounded by looking at carbon-based life, because at least that is probably a prerequisite for any future silicon-based life. Computers and robots may well be our evolutionary descendants, but they wouldn't be that unless there were humans and carbon-based life that created them. So let's focus initially on carbon-based life. So one way of looking for life is to look for biosignatures in spectra. And first you find the so-called transiting planets. Planets in orbital planes that are edge-on to our line of sight, once per orbit, cross across the face of the star and dim its light a little tiny bit. So when that happens, you can see that the star looks a bit dimmer. Now here, the 0 point on the ordinate, the y-axis, should be way down in the ground somewhere. This is 98, 99, 100. So here, the light has only been diminished by about 1.5%. That's sort of like a giant planet. Jupiter is about 1/10 the diameter of the sun, so its cross-sectional area is about 1/100th of the sun's cross-sectional area. So Jupiter would cause a 1 slightly bigger than 1% dip. So this is a Jupiter-sized planet. an Earth-sized planet would create a much, much smaller dip. But in any case, you look for these transits, all right? And then you look at the spectrum of the star, both during and not during a transit. And you look for differences in the spectrum. And the idea is, going back here, that the opaque part of the planet blocks the starlight completely. But there's this potential atmosphere around the planet that can selectively absorb certain wavelengths depending on the atoms and molecules in that atmosphere. And so that's how we might detect possible biosignatures. And the proof of concept was done more than a decade ago, even with the Hubble Space Telescope, where for this star, HD 209458, they took a spectrum both during the transit and before or after the transit. And the point is that the relative strength of this pair of lines here, caused by neutral sodium, was greater during the transit than not during the transit. And so that identified the presence of sodium atoms in that exoplanet's atmosphere. So one of the first very exciting results from the James Webb Space Telescope, and this was announced August 12th of 2022, just last year, was that they were able to get one of these so-called transmission spectra of the exoplanet going around the star WASP 96b, which is about WASP 96. And the exoplanet is called WASP 96b. And it's about 1,000 light years away. And so here's the brightness versus wavelength at infrared wavelengths, because that's what James Webb Telescope is good at. And the data points are kind of noisy, but that's okay. This is a difficult measurement to make. The best fit model, this blue curve, shows the pretty unambiguous, to my eye, presence of water. And that's very exciting because astrobiologists have this mantra, follow the water. Again, for life as we know it, it's all water-based. Let's initially at least follow the water. And then maybe later on we'll find, computers or AI or something like that, So this is very exciting. It bodes well for the future. The hope is that future spectra of the James Webb will look something like this. Now, this is a synthetic spectrum, okay? This is not an actual spectrum, but this is the kind of thing we hope to see. In particular, the simultaneous presence of methane, CH4, and oxygen, in this case, the form of ozone, which in our atmosphere, of course, blocks most of the ultraviolet. The simultaneous presence of them is a possible signature of life. The point is that methane oxidizes very quickly. And so if you see methane and oxygen simultaneously, there has to be some more or less continuous production of the methane. Otherwise, it would all have oxidized. Now, there are abiotic ways of producing methane. Indeed, we see the concentration of methane changing in Mars's atmosphere, but not many astrobiologists or astrophysicists are yet convinced that we've found unambiguous evidence for life on Mars. And that's because chemical reactions of a non-biological nature can produce methane. But methane can also be produced and is produced by, decaying organisms. Carl Sagan called it bovine flatulence, all right? Although in the case of cows, I think it's mostly burps, not farts. But anyway, this would be very exciting. It would be not a clear signature for life, but it would be then the type of signature where other astronomers using various telescopes, radio telescopes throughout the electromagnetic spectrum, they would start examining this exoplanet, this hypothetical exoplanet, very carefully to look for other more compelling signs of life. One could even imagine finding technosignatures in the form of pollutants. For example, if one saw chlorofluorocarbons, right, like in refrigerants, CFCs, we think there's no easy way to naturally make large amounts of CFCs. But humans do, again, through refrigeration type systems and stuff. So, or other types of pollutants that are unlikely to have been formed in a way that was not associated with life. That would be very exciting. Okay. All right. Moving on, though, I hinted at this already, technosignatures. I've got a lot to cover today, so I won't go into these in great detail, but the usual thing people have thought about has been radio signals. Pi transmitted to us 100, 1,000, 10,000 digits over and over again. To me, unless one could show that that was a hoax, or more likely a hoax, that would be an eyebrow-raising piece of data. And of course, with the Very Large Array and the now defunct Arecibo radio telescope in Puerto Rico, radio astronomers have been searching for these signals for over 50 years now. The Allen Telescope Array in Northern California searches for them, and the SETI Institute in Mountain View is charged with analyzing the data. And in fact, you, the audience, can participate in the search. Go to seti.berkeley.edu. There's essentially a screensaver that you can download while you're sleeping and not doing anything useful. The program will analyze packets of data that are sent to you. This was organized by my colleague Dan Wertheimer and his colleagues. It's called the SETI at Home project, but there's something like 6 million computers, I think, throughout the world participating in this. And so there's a small but non-zero chance that you could provide, through these radio data and your computer's analysis, the first real evidence for extraterrestrials. So I encourage you to get this screensaver. Go to SETI at Home. Okay, other technosignatures. There are these things called fast radio bursts. They last just a tiny fraction of a second. We actually think that they're highly magnetized neutron stars that go through essentially starquakes that change the structure of a very strong magnetic field, and that releases radio radiation. But the alternative of aliens trying to communicate has been entertained. I don't find it a very convincing argument because these fast radio bursts are all over the place in different parts of the sky, billions of light years away. So everyone else is part of this club and we're not. I don't know. They've all learned how to communicate with each other despite being in completely different galaxies. I sort of doubt it. Brief optical pulses also you could look for. Most of the time when people take pictures of the sky, the exposures are pretty long. And so short pulses would get smeared out. Laser light, which is monochromatic, is a good way to look. And a number of my colleagues are examining high dispersion spectra of stars. That is, they made a big, huge dispersed rainbow. And for other reasons, they want to study the chemical composition or whatever. But they can look, for example, for the sodium lines or other laser lines. Okay. Some of you have green lasers. They shine because of the sodium line. Dyson spheres, I'm sure many people in the audience have heard of. Presumably, if we last long enough, we would like to capture not only the sun's radiation, which lands on Earth, but capture that radiation which escapes to outer space. And you could build a sphere or some network of, ribs or something around the sun or around other stars and capture more of the radiation, the optical light. But the energy has to get out somehow. And so things heat up and they then emit in the infrared. So we could look for infrared bright stars. We could even image or detect light from cities if they're big enough and if our telescopes are good enough. Already from Pluto, using today's telescopes, you could detect major cities on Earth. Okay. Pollutants in exoplanet atmospheres, I already mentioned. Alien satellites orbiting exoplanets. You're aware of Starlink and everything. Every once in a while, like I look in the sky after they've launched these things and there are these bright stars wandering around. I wouldn't be too surprised if within a few decades, the night sky were dominated not by the constellations of fixed stars, but by these moving things. And I think that'll be a sad day. But once there's enough of these things, you could actually even hope to detect them perhaps orbiting other planets, if the aliens behave anything like what we've been doing. Then there's the issue of alien light sails. So what's a light sail? All right, Japan's Icarus thing is an example. It's just a very thin, big, flat sheet on which impinges radiation from the star, in our case, the sun, and that propels it outward. The Planetary Society has had one of these things. They launched it a few years ago. You can accelerate objects with just the sun's radiation. You won't get them going very fast, but you can get them going, and then they could travel for millions of years and reach other stars. So it's not a completely far-fetched idea. What is far-fetched is the hullabaloo that Avi Loeb has made of an admittedly weird object called Oumuamua, which in native Hawaiian means scout or early scout or messenger. It's a very interesting discovery in 2017. It had a very high speed, greatly in excess of the solar system's escape speed. So it was clearly a visitor from another planetary system. About that, essentially no one disagrees, okay? Its light curve or brightness versus time is very strange. Astronomers use these weird units called magnitudes, but bright is up and faint is down. So you can see this thing goes through these cycles. They're not exactly periodic, but there's a variation of about a factor of 10 in brightness, which is quite unusual for asteroids and comets. Not completely out of the question, but indeed quite unusual. So simulations suggest that this thing is tumbling and that it's either cigar-shaped and long, or much more likely flat and pancake-shaped. There's sort of a 90% probability that it's a flat pancake and only a 10% probability that it's a cigar-shaped thing, although the cigar-shaped thing was the first that was proposed. And so most of the pictures you can find online, the artist conceptions, show the cigar shape. So it's tumbling because the light curve is not exactly periodic, all right? And it's a big flat pancake. That's very interesting. So here's one of these early artists' impressions, although it's probably a thin, flat sheet. Okay. Next weird thing. It didn't slow down as much as expected when it was going outbound from the sun. You'd expect it to slow down because of the sun's gravity pulling on it, okay? But it didn't slow down as much. That's not to say that it accelerated and got going faster. It did slow down, but not as much as expected. So perhaps radiation pressure was pushing on it, just like a solar sail. That's the idea. And Avi Loeb has been promoting this, first quite gently and conservatively, in a research paper that he and a student published in the Astrophysical Journal. It was almost like an afterthought in the last paragraph, okay? But then in the public forum, on various podcasts, and in his book, Extraterrestrial, he's come out far, far more strongly than in his scientific refereed publication. And by the way, I have the highest regard for Avi Loeb. I've known him for decades. He's a very, very smart guy who's written lots of very interesting papers. But here, I think he's completely on the wrong track. And I don't know why. I don't want to spend the whole hour on this. Let me just give you a few things. But if these things were being randomly sent out and not specifically aimed toward us, then you need 10 to the 15th of them per star if they're random light sails. Now, Avi has used this number, 10 to the 15, to argue that they're not weird comets or asteroids, because that's a lot to be coming per planetary system. And I don't disagree. But it's even more if you say it's an alien spacecraft and all the other stars, the 100 billion stars in our galaxy, all have alien civilizations that are doing this. I think it's much more likely that there's some more natural, not alien associated way of producing these things in giant numbers. Maybe you don't need even 10 to the 15, maybe 10 to the 14 or 10 to the 13, whatever. Oops, my light just went off. Let me turn it on for any of those who are looking at me. Okay, so it had to be deliberately aimed at us, and he doesn't spend a lot of time talking about this. A few people have painted him into this corner, but I think he knows that it's a weakness in his argument, and so he actually doesn't spend a lot of time on the podcasts and stuff admitting that this thing had to have been deliberately aimed at us. Or his other thing is that there's a bunch of them in our solar neighborhood, and they're like buoys. There are a bunch of them, and they're being used to navigate or something, all right? But again, they're either buoys everywhere in our galaxy, in which case there's just ridiculous numbers of them, or they're buoys only in our part of our galaxy, in which case the aliens really did this in our part because somehow they're interested in us. If it was deliberately aimed at us, and if, by the way, it also wasn't aimed very well. It missed us by a lot. Whatever. Okay. Are we really that interesting? If this thing is that advanced, if it's a billion years ahead of us, or aren't we like just microbes? And sure, there are biologists on Earth interested in microbes, but there are probably lots of microbes in the galaxy to be interested in. I doubt they would find us that interesting if they've reached that kind of interstellar capability. It wasn't aimed at us very well. It doesn't reflect all colors well. You'd think that a light sail would reflect all the colors of stars very well in order to get propelled faster. Instead, it has the reddish colors typical of some classes of asteroids and comets. There are no radio signals detected from it. People have looked carefully. And what's particularly annoying to me is that Avi keeps quoting Sherlock Holmes, I believe from The Sign of 4. When you have eliminated the impossible, whatever remains, however improbable, must be the truth. Well, yes, I agree with that. If you have eliminated all of the impossible conjectures, okay? But he hasn't. All other options have not yet been eliminated, not even close. And so his repetitious referral to this quote, I find frankly annoying. So let's look at some more natural explanations. A comet from another planetary system, outgassing from the sun-facing surface, caused it to deviate from gravity-only trajectory. Okay, this is a very well-known phenomenon. Now, most of you know that the tails of comets point away from the sun, but that's only after the gas has been ejected. It gets ejected from the heated side of the comet, the dirty ice ball or the icy dirt ball, the thing that's facing the sun. That's where the sublimation goes. And then radiation pressure and ions push the thing away from the sun. So yes, by the time the tail grows big, the tail is away from the sun. But initially, it's toward the sun, and the back reaction, the conservation of momentum, would give the object a push in the outward direction when it's outbound. So this has been seen in lots of comets. The problem, and I admit it's a problem for Oumuamua, is that we didn't see any outgassing. And in particular, molecules like carbon dioxide and carbon monoxide, I think, were searched for and would have been seen. So it's not a typical comet. I agree. It's some sort of a peculiar comet. What kinds might there be? Well, one idea is that it's a molecular hydrogen ice fragment that form deep in a molecular cloud. The problem with that is that it's more likely than not to have evaporated along the way to us, because these things move slowly and the nearest molecular clouds are quite far away. There's one in Orion, 1,400 light years away, and so on. So I agree with Avi's criticism that the H2 ice fragment would likely have evaporated along the way. But other hypotheses have been proposed. A nitrogen ice fragment could be from a disrupted Pluto-like object. Now, Pluto has been visited by the New Horizons spacecraft, and there's lots and lots of ice on it, and it's nitrogen ice. And the early solar system may well have been a very violent place where lots of planets or dwarf planets, whatever you want to call it, formed, and some of them crashed into each other. That would form a spray of debris, maybe even 10 to the 14 or 10 to the 15 of them, right? And they would be nitrogen based. And they could survive 500 million years, okay? Not that hard, actually. So this is a possibility. And then more recently, a colleague of mine at Berkeley, an astrochemist, Jennifer Bergner, has put forward with her colleagues a hypothesis that it's essentially a normal comet from another planetary system that's outgassing hydrogen. And the hydrogen comes from water that was split apart by cosmic rays, energetic charged particles, on its way to us. And this phenomenon would be most visible for relatively small comets, not big ones, because the surface area to volume ratio is bigger for small things than for big things. And Oumuamua was probably pretty small. We don't know exactly how big it was because we don't know its albedo, its reflectivity, but it was probably about the size of a football field. And by the way, things sputtering off an initially asymmetric or aspherical object. Imagine a bar of soap. This is the analogy that's often given. And you're gradually removing equal amounts from all sides of the bar of soap. So you start with a rectangle, but it becomes flatter and flatter because imagine removing a centimeter from all sides. Now the length is only a little bit, 2 centimeters shorter than the long part was to begin with, but the width is 2 centimeters smaller as well, but that makes the whole thing thinner. So natural erosion traveling through interstellar space could explain the very flat, unusually flat shape of this object. And this is just the latest idea. This just came out a couple of months ago. So there may be others as well, okay? But the point is, Holmes's dictum cannot be applied. All right? Okay, enough of that. Alien landings or crash sites, alien sightings. This is, of course, a popular one. Area 51, a U.S. Air Force facility. So it's just grist for the conspiracy theorists. And of course, there's even been movies. The alien Paul from Area 51 in the movie Paul. Notice the incredibly humanoid shape, by the way. Roswell incident in New Mexico. Yeah, folks, it was a nuclear test surveillance balloon from Project Mogul. And guess what? The military wants to keep these things secret from us because they don't want our adversaries or potential adversaries elsewhere finding out what we're doing. So of course there's classified stuff. And then eventually, debris is found or whatever, it becomes unclassified. And, in fact, the military that's developing these things, if that's what they're doing, which they are historically, at least in certain cases, and probably even now, the whole alien UFO UAP thing is a great distraction. They're all like, let everyone think that they're UFOs, UAPs, actual crashes of aliens. That diverts attention from them. But yeah, there's classified stuff, folks. Here's the this is from the UFO Museum in Roswell. I don't know what they made this creature out of, some sort of plastic or something. Who knows? I've never been to that museum. Of course, there's some publications that are perhaps not as reputable as the Astrophysical Journal and other peer-reviewed ones. UFO base found in New Mexico, and aliens visited Fergie's baby, says stunned British press. Well, don't believe everything you read. Alien backs Clinton. I'm happy he saw through Bush and Ross Perot. This is several decades ago. That alien, or perhaps a close brethren, some years later changed political allegiance and even supported our former governor. Hasta la vista, Gray Davis. Anyway, when I'm like in Safeway and I'm buying groceries and I'm standing in line and I look at these tabloids and I just laugh. And then I become depressed because I realize that millions of people believe this stuff. Okay. Well, how about the alien spacecraft, about which much has been made in the press recently? UFOs, now the more politically correct abbreviation, or the abbreviation is UAP, but unidentified aerial phenomena, or unidentified. There's another possibility for the A. I've now forgotten what it is, but this report called it unidentified aerial phenomena. This came out of the Office of the Director of National Intelligence. And basically, most of the objects are reasonably easily explainable, or at least plausibly so. Some of them are not, but the data are generally not very good, and that's why they're not explainable. Fake UFO photos go back decades. Here's J. Allen Hynek, who was, if anything, a big UFO enthusiast, but showing a photo of a fake UFO at a 1966 press conference. Much has been made of the various Navy pilot videos. Okay, you can find them on YouTube and stuff. All right. Much has been made of them. And Mick West, who I believe has given at least one talk to one SkepTalk, if not more. Again, I have lots to cover, and he's much more of an expert on this than I am, but he spends a great deal of time trying to figure out how these, what these things might be. He's a UFO debunker, and he's come up with quite plausible explanations for essentially all of them. Maybe not quite all of them, but again, the data don't get any better. That's the other frustrating thing. So in particular, you can look at his website on YouTube and stuff. I'm surprised that they get so few views compared to, say, the Kardashians or whatever, but I guess that's the way it goes. Here's a nice opinion piece by Mick a couple of years ago. The aliens haven't landed. Why you should be skeptical of recent reports on UFO sightings. Close examination of supposed UFO videos by myself and others has shown them to be far more mundane than first thought. So in particular, I just wanted to highlight a couple of things from this article, okay? He says he's a big science and science fiction fan. He would love to find evidence for aliens. He lives for aliens, in a sense. But to quote him, this current flap isn't it. In 2017, he helped solve a very, very famous UFO case. The Chilean Navy video showed a mysterious object. A 2-year study was conducted by an expert panel consisting of people from the military, scientists, engineers, etc. They concluded that it's a genuine certified UFO. A 2-year study by an expert panel. All right. 3 days later, I and others identified the plane as Iberia Flight 6830, departing Santiago Airport. The hot gases, he's talking about some of the supposed evidence, were just contrails, and the odd movement was the result of a low viewing angle and a powerful zoom factor on the infrared camera. The glare from the engines obscured the plane and created the unusual shape. Radar data confirmed that the exact location of the plane matched the UFO. Case closed. UFO enthusiasts were annoyed. He goes on to say something similar seems to be playing out with the current situation with the US Navy. UFO enthusiasts claim that there's amazing evidence of UAPs representing something incredible, and that a special group has been investigating this for years. As with the Chilean case, we are shown blurry video from military-grade infrared cameras as highly compelling evidence that has apparently resisted analysis. But he goes on to say, when the evidence is scrutinized by himself and by others, the claims almost invariably fall apart. And an example is this gimbal video, which it went viral, okay, which seems to show a flying saucer skimming the clouds. Actually, it's the infrared glare from the engine of a jet, okay? The camera had derotation mechanism used to correct for gimbal roll, and the glare should rotate as seen in the video. So he explained it. Is this definitively what it was? He doesn't know, but it's a very plausible explanation. Moving on, other videos called remarkable videos, UFOs. The go fast was not going fast. It was likely a balloon drifting in the wind. The fast motion was an optical illusion, which you can easily get against a backdrop of clouds or whatever. The very famous Tic Tac that Jim Ferver, or I may be mispronouncing his name, I should have looked it up, but he became famous for it, right? Looked like an airplane with an apparent movement caused by camera switching modes and doing gimbal rolls, okay? That's probably what the Tic Tac was. The Green Pyramid, quote, best UFO footage of all time for 2 days. Out of focused airplane shot with a triangular aperture. Now, who knows why the photographer was using a triangular aperture? Maybe for special effects. You've seen them use different apertures. The diffraction pattern produces interesting patterns. That's a reasonable explanation for the Green Pyramid. So the evidence is underwhelming. Okay. All right. What could UFOs, UAPs be? Airplanes, mirages, optical illusions, atmospheric phenomena, flaws in newly deployed radar systems, visual artifacts in cameras, birds, drones, right? US drones, possible adversaries. We do need to find out what these things are. I'm not saying stop research on this. This could be a serious threat from adversaries here on Earth, right? Or it could be secret classified missions that, Americans are conducting. But we do need to find out what these things are. Advanced technology of other countries, that's possible too. These are possible adversaries. And as I said, secret US military technology, and calling them alien spacecraft provides a wonderful distraction. This has been in the news a lot lately, the past few months, because of the suspected Chinese spy balloon that was shot down. And in the weeks immediately following that, several other things were shot down. There was sort of everyone was on the alert. Here's from CNN, February 12th, 2023. High altitude object was shot down near Lake Huron on Sunday afternoon, marking the 4th time in just over a week that the US military has taken down objects in North American airspace. Is it happening more frequently than it used to be, or are we just more on guard? We don't know. It says here there's no indication at this point that the unidentified objects have any connection to China's surveillance balloon, but it seems that national security officials across the continent remain on edge. Yeah, we do need to find out what these things are. There is no physics that's violated No law of physics is violated if an alien spacecraft reaches Earth. Pioneer and Voyager, two of them each, escaped from our solar system and are flying through the galaxy. They're technically still within the Oort cloud, so by that definition, they have not yet escaped our solar system. But you can calculate that in some millions of years, the Voyager spacecraft is going to pass quite close to various stars. There are lists of them. You can find them online. If there's a planet with aliens there, sufficiently advanced, they could notice it. They could capture it even. If they don't know about us or aliens in general, they would be amazed. That's very different from these things flying around, staring through your kitchen or into your bedroom, abducting your children, et cetera, right? Snooping around, that kind of thing. This is just a flyby. Again, it doesn't violate laws of physics if hibernating computers on spacecraft took millions of years to get here and then got out of their little cocoons, their spacecrafts, and went snooping around in people's kitchens and stuff. But the evidence is underwhelming. So I don't deny that it's a possibility, but I sure don't think the weight of the evidence comes anywhere close to the standards that scientists now demand. Okay, getting near the end here. It's still interesting to ask yourself how many communicating civilizations there are in our Milky Way galaxy right now. You could just say 5, you could say 1 billion, you could say none, except for us. Those would be just guesses, but you can have a guess which is based on some reasoning, okay? And this, as most of you know, is known as the Drake equation after Frank Drake, who quite recently passed away, okay? And it was a way of trying to use known factors to tie down the numbers, restrict them at least a little bit, and if nothing else, show you which factors need the most improvement in order to decrease the uncertainty in the final estimate. It's sort of like I tell my students in my introductory astronomy class at Cal, let's try to estimate the number of perfect bookstores in Berkeley. And perfect bookstore might, that definition may depend on the person. But anyway, I show various things and I calculate there are 2.2 perfect bookstores in Berkeley, according to my criteria. Or it's often said that any good physicist should be able to estimate anything to within a factor of 10. And the classic example is the number of piano tuners in Chicago. It's not going to be 10 billion because there's not even 10 billion people on Earth. It's going to be more than one because there's a lot of pianists in Chicago. Okay, can we somehow, restrict that range even more and figure out what the most uncertain factors are? That's the spirit of the Drake equation. It is not a precise thing like E equals MC squared or F equals MA or whatever. Okay, it shouldn't be used that way. All right. So the number of communicating civilizations in our galaxy right now, N, is equal to a product of a bunch of things. Average rate of star formation. The more stars that form per year, the more likely it is that there are some communicating civilizations. The more bookstores that form per year in Berkeley, the more likely it is that there's going to be a perfect one. F sub p, the fraction of stars with planetary systems. N sub e, the number of planets or moons per star in the habitable zone or tidally heated or whatever, okay? F sub L, the fraction of those moons or planets on which life actually develops. F sub I, the fraction of living species that develop intelligence. F sub C, the fraction of those living species that reach the electromagnetic communicative phase. And then finally, and very importantly, L, the lifetime in the communicative phase. Notice that's in years. R was a star formation rate per year. So the years will cancel out, giving us a pure number. Okay. So here's an estimate. I'm just going to put in some numbers, okay? Optimistic numbers and pessimistic numbers. Not even the most pessimistic that I could conceive of, okay? Probably the most optimistic, however, that I could conceive of. Okay, rate of star formation, 1 to 2 stars per year in our Milky Way galaxy. That's right now. You could argue that the number is more like 10 in the Milky Way's heyday, some 7 or 8 billion years ago when star formation was greater. All right, so maybe I should put in 1 to 10 then. Fraction which have planets. You know, the Kepler spacecraft showed that 1% of all the stars in the field in Cygnus and Lyra at which they stared had edge-on planetary systems that underwent transits, but only 0.5% to 1% of randomly oriented planetary systems will be along our line of sight. So the Kepler data are pretty convincing that most stars have a planetary system. I'm not going to worry about orders of magnitude here, even though I did give a 2 here. You could call this 0.8, 0.9. I'll just call it 1. Okay, I'll give it to you. They all have it. The number of moons or planets in the habitable zone. It used to be thought that it was 1, Earth in the solar system, Venus almost, Mars for a while. But now that we know that various moons, Enceladus, Europa, might have primitive life, you know, or at least might have conditions suitable for life, there could be several. Or since most stars are little tiny M dwarfs whose range of distances is quite narrow, where a planet would have the right temperatures, depending on its atmosphere and all that, of course, but the right temperatures to have liquid water. It's a pretty small range, although some M dwarfs like TRAPPIST-1 have been found that have multiple planets in the habitable zone. So let's just make 0.1 a pessimistic estimate and 5 an optimistic estimate, but already the range is becoming bigger. We just don't know. Okay, now we get to the biological aspects where we really don't know, right? We have one example of life on Earth. It all came, we think, from the same origin. So is that inevitable, given conditions that are conducive to the formation of complex molecules that can reproduce and evolve? Maybe. Some people say yes, because there's evidence, chemical evidence for life on Earth 3.8 billion years ago, fossil evidence from 3.5 billion years ago, and the so-called era of late heavy bombardment ended 3.9 or 4.0 billion years ago. So within 100 or 200 million years of conditions becoming suitable for life, life did actually form on Earth. And so that's an argument that given suitable conditions, it forms easily. But one could also argue that it was just a fluke, right? It's 1 in 1,000. And it took an early generation or generations of microbes and bacteria billions of years ago to allow billions of years of evolution to get to us. Suppose more typically, it takes 4 billion years for a bacterium to form, and then 4 billion years to get to us. Well, then, you know, many stars won't have lived long enough or won't ever live long enough to do that, you know. So who knows? But a pessimistic estimate, since we don't know how life arose on Earth, might be 1 in 1,000. But I could imagine that life is even more rare. So that's not the most pessimistic estimate. How often does intelligence and mechanical ability at our level form? Holy moly. We have no idea. But I'll have some arguments in a minute or two, a couple of minutes, that it's really rare. All right. Maybe it's inevitable. So I'll give the optimists the 1. But maybe it's 1 in 10 million. Maybe it's 1 in a billion. Right? We have no idea. And then those that become intelligent, the fraction that are able to and want to communicate over interstellar distances. You know, whales and dolphins are pretty smart. They can communicate with each other, but they can't communicate over interstellar space. So again, I'll give the optimists a 1, but it might be 1 in 1,000. It might be even worse. And then another very uncertain factor is the lifetime in the communicative phase. We've had it for about 100 years since Marconi and others, right? And I hope this is not the case, but we could destroy ourselves intentionally, unintentionally, or through neglect in the near future. So if we're typical, and they typically last 100 years, that's pretty sobering and won't lead to a very large number. But if we're able to overcome our current woes, maybe we will thrive for 1 billion years. So let's multiply these numbers together. If you multiply the optimistic ones together, you get 10 billion communicating civilizations in our Milky Way galaxy right now. Okay, great. They're all over the place. But if you multiply the pessimistic numbers together, you get 10 to the minus 12, 1 in a trillion. And you're familiar with the Hubble and now James Webb images, through extrapolations of which we estimate that in the observable part of the universe, there's something like 1 trillion, that is 10 to the 12 galaxies. So 10 to the 12 times 10 to the minus 12 is 1. We are it. That's not completely unreasonable. My own feeling is it's somewhere in between. Maybe we're the only ones in our Milky Way galaxy. But maybe it's 1 in 100 galaxies. Maybe it's 1 in 1,000. I'm not quite this pessimistic. I certainly don't think we're alone in the total universe, what extends even beyond the observable parts. But I'm nowhere near this sort of an optimist. And I think Carl Sagan's number was 100,000, 10 to the 5 from the Drake equation. Here's a JWST picture, which is just stunning, not because of this ugly star with a diffraction pattern, but because of the tens of thousands of galaxies in this picture. It's just amazing. And people say, there's so many stars per galaxy and so many galaxies in the universe. Surely there must be intelligent life. Well, it's not so clear to me. Maybe there is. I hope there is. But if our Milky Way galaxy is teeming with intelligent life, where are they? Where are they? Something known as the Fermi paradox. Not because Enrico Fermi was the first to state it. Other people had thought about it, but supposedly there was a lunch at the University of Chicago and they're all sitting around discussing something else, I think. And suddenly he said, where are they all? And he didn't even have to give context. I mean, there were different stories. This may be an urban legend, but everyone immediately knew what he was talking about. If there are so many aliens, why haven't we definitively seen them? Why aren't we the aliens? Right? So here are the possible explanations. Last 5 minutes here. They never achieve interstellar travel. They don't want to colonize the galaxy. They're smart. They realize that that real estate is limited, and then the next galaxy is really far away. Andromeda is 2.5 million light years away. They have visited, but they want to leave us alone, like Star Trek's Prime Directive, right? Don't interfere, even if you see them about to destroy themselves and you could save them. We are so primitive compared to them that they aren't interested in us. This is what I mentioned earlier in connection with Oumuamua. Now I have a blank line there, so a pause. And then here are the things I think are the primary factors, although I don't deny that these other ones may also be factors. I personally, and this is a personal thing here, so I have no proof, I have no hard evidence, but I personally think they're very rare. Intelligent life springs up very rarely. And even if they aren't very rare, right, they might be common, or they might be very rare. But even if they aren't very rare, they usually destroy themselves or get destroyed before reaching interstellar travel capabilities. one or more great filters. And I think it's both of these factors as the solution to Fermi's paradox. Why do I think that? By the way, here's the dinosaur seeing the asteroid. With our intelligence, we could actually be the first species that saves our own extinction, right? But the dinosaurs didn't. All right, what do I mean by a great filter? So this is an idea due to Robin, oh, damn. Robin, he's an economist, but I'm suddenly in this talk forgetting names, and I have an excuse. I observed with the Keck telescope last night, and right after this talk, 10 p.m. Pacific time, I'll start observing again. So I'm a little bit Robin something. I'll think of it later. Okay, there's the origin of life, and then there's various commonly achieved evolutionary steps. And here are various species that make it through these commonly achieved evolutionary leaps. And then here's an evolutionary leap that almost no species manages to make. So that would be what's called a great filter. And one species made it through. And then there are other evolutionary leaps. And then it becomes a type 3 civilization, which colonizes all the stars and uses up all the energy. So you have an infrared bright galaxy. We don't know of any such galaxies, by the way, that emit entirely in the infrared and none in the optical. So we have no evidence for type 3 civilizations. Okay, so here are the possibilities. We're rare. Here we are. The great filter is behind us. We made it through. We're really lucky. Sorry, we're here. We're the orange thing. And then here's one other odds-defying species. Most of them didn't get through. And here are evolutionary leaps not yet proven to be common or rare to make successfully. So we could be rare, okay? And the great filter is behind us. That means we have a long and prosperous future ahead of us. We're first, or among the first. So here's all these species that some of which make it through various evolutionary stages. And we're sort of at the head of the pack, or among the first. And the great filter is actually ahead of us. Or, sorry, this one is orange. This one isn't even necessarily a great filter. There aren't necessarily great filters, but we're just among the first. So we're rare, we're first or among the first, or we're screwed. So that's when the great filter is ahead of us. And here are all these species that have made it through relatively easy evolutionary jumps. And then they get blocked. And occasionally one or two or three will get through, but they're very rare. And we're not one of those rare ones. That was 2 slides ago. We made it through. Here we're screwed. So some possible great filters. The right star system, including organics and habitable planets, the rare Earth hypothesis. Reproductive molecules with RNA might be a big evolutionary leap. We just don't know. Simple prokaryotic single-celled life may be the big evolutionary leap. We just don't know. Complex eukaryotic single-celled life might be the big evolutionary leap. We just don't know. Sexual reproduction might be it. Multicellular life might be it. Tool-using animals with intelligence might be the great filter. Most just don't get to that part. And then a civilization advancing toward the potential for colonization explosion. That is where we are now. But then which destroys itself or gets destroyed through negligence or intention. And then the colonization explosion. which then, if it happened, would raise the Fermi paradox, right? Okay, so Nick Bostrom, an Oxford University philosopher, has thought a lot about this. He says, no news is good news. The discovery of even simple life on Mars would be devastating because it would cut out a number of potential great filters behind us. That is, steps 2 through 6 are easy. If we found other places that got to this point, these steps are easy, and what's ahead of us is hard. And if we were to find fossilized complex life, like trilobites on Mars, Bostrom says, it would be by far the worst news ever printed on a newspaper cover, because it would mean that the great filter is almost definitely ahead of us. That is, steps 1 through 7, maybe even 8 are easy, right? You get to tool using animals. You even get to a civilization advancing toward the potential for colonization explosion, right? If we were to find monkeys, indigenous, independent of Earth monkeys elsewhere, that would be devastating. So the great filter would ultimately doom the species. And Bostrom believes that when it comes to the Fermi paradox, the silence of the night sky is golden. So my reasons for thinking intelligent life is rare. Earth, the only example we know of, one species, Homo sapiens, out of, and biologists argue about this, but call it 100 billion species or more in the history of life on Earth. Call it 10 billion if you don't want to believe 100 billion. There's no evidence that anything like us has ever existed. There's some debates about whether we would know by now because things get destroyed. But I think even the fossil evidence, right? We know the dinosaurs. We can go back to the trilobites. Before that, there wasn't much of anything hard-bodied. Single-celled life clearly dominated for 2 billion years or more. So I don't know. Maybe there was something since the trilobites, but I really doubt it. There would be other things in that lineage, I think, that would be comparable to us. Our brains are amazing. We are an astonishing species, and our opposable thumb is amazing. There's nothing quite like us. Dolphins and whales are intelligent, but there's no evidence that they think abstract thoughts and try to answer questions just because of the sheer intellectual stimulation. And they certainly don't have the opposable thumb with which to build machines to explore the universe. Second argument, we appeared only 250,000 years ago. Homo sapiens, that is, and early hominids 4 or 5 million years ago, after nearly 4 billion years of evolution of life on Earth. Over most of Earth's history, an intelligent alien looking at Earth, flying by, would have said there's nothing particularly intelligent or mechanically able on Earth. So I think we're an evolutionary fluke based on that argument. A highly improbable evolutionary outcome. And then finally, it's not clear to me that our intelligence and mechanical ability is a long-term evolutionary advantage. Yes, we've improved the lives of hundreds of millions of people in the last few decades, but look at also what we're doing to Earth. We're the first species that can, and I hope won't, but might destroy itself. So the honest possibility, despite how odious it may seem, is that we might not last long. And so if we're typical of these things that occur, rarely, I think, but even perhaps commonly in the galaxy, they would be flash bulbs in the night. This is something that always or almost always is a weakness of these intelligent creatures. All right. Now, as I said, we could be the first species that helps prevent such a thing, an asteroid or a comet hitting Earth. Some of you followed the DART mission. Fabulous success. The first step in protecting ourselves from the incoming asteroid, if not the comet, which comes in with no warning. But the asteroids you can track for, decades in advance. And then, there are various ways you can smash things into them. You can have gravity tractors. You detect the thing a century before it hits Earth, and just the tiniest pull will deflect it. So we could save ourselves, but there's also many, many more ways we could doom ourselves. Save yourself, mammal. We will fend off the asteroids, the dinosaur possibly said. Well, we'll see. So my personal opinion to end this with is, at a given time, creatures as advanced as humans are present on very few planets, perhaps only one in the Milky Way Galaxy. And that's not even saying that every galaxy has one. It could be 1 in 100, 1 in 1,000. Could be 1 in a trillion, though I'm not that much of a pessimist. They generally don't last long enough to achieve interstellar travel, or at least not interstellar colonization. The great filter is self-destruction, or one great filter, relying on young people to get us through the next great filter. Now, I'm not saying people my age should just give up and we've screwed up this planet for all the youngsters, but you youngsters have more of the clever ideas. You're not set in your ways. You have more time. So I'm not saying I shouldn't do this, but I've got other research I'm doing to which I devoted my life. And I'm hoping for the young people listening to this talk, you'll help us get through the next great filter. And despite my skepticism, I firmly believe we should continue to search for signs of extraterrestrials. So I very much value what my colleagues Seth Shostak, Jill Tarter, and others are doing at the SETI Institute and elsewhere. Yuri Milner is spending lots of money on Breakthrough Listen and even Breakthrough Starshot, which is to send a little probe at 20% of the speed of light to Alpha Centauri and take some pictures of the exoplanets. So we should continue seeking, even if I don't think we'll find. Finally, the search for space aliens comes up empty, but extraterrestrial life could still be out there. I do agree with that. Okay, well, listen, I've gone on a bit long, but I was told that there's no speaker after me the way there is at a conference. So I hope you enjoyed that, and I'm available for questions pretty much as long as you would like.
Yes, that's absolutely right. We didn't, we did tell you that it was to take as much time as you want, mostly because we knew that you would give us an awful lot of interesting information and things to think about, and you certainly did. Yeah. So that was really fun.
Well, thank you.
I'm always struck when my background's in anthropology, so I tend to think in terms of biology and morphology and things like that. And it always just drives me nuts, the anthropomorphism of aliens. You right. showed the typical, big dome, big-eyed, etc. They're neotenous, but they don't really look very gentle and friendly, but that's another issue. And there's such a lack of imagination as to what an extraterrestrial would be like in terms of its appearance and its abilities. There has to be, as you pointed out, some ability to manipulate, because otherwise you don't go anywhere. Right. Dolphins and dolphins are great, but they're not going to build the pyramids. Do you remember the cartoon Frank and Ernest? It might still be around. I don't know, but our local papers don't carry it.
I don't remember much of it.
It's a great cartoon. Yeah. There was a cartoon from Frank and Ernest I used to show a lot. It showed these two little angels sitting up on a cloud looking down at Earth, and Earth was kind of like that, that planet that you showed before, the dinosaur and the mammal, but it was sort of explosions taking place, and obviously all hell was breaking, and it was a big mess. And the angels looking up at God and saying, "It's the monkeys. I told you to give the hands to the dolphins."
That's a great one.
It was, Frank and Ernest.
By the way, Jeannie, I just because I wanted to give credit where credit is due. Robin Hansen. Hansen is the last name. That's what I was just.
Very good.
Yeah, Hansen with an O. Robin Hanson, an economist, actually, in 1998 or 99, wrote a paper about the Great Filter and stuff. But yeah, he gave the hands to the monkeys, and so that was a big mistake.
So here we are. Have you? But speaking of the appearance of extraterrestrials, have you read Andy Weir's latest book?
I have not.
I would recommend it to anybody watching this. It's called Project Hail Mary. Came out a year or so ago, and it's a very like those of you who are wondering what we're talking about. Andy Weir wrote The Martian. I ran into somebody the other day who said, "Oh, that was a book." Yeah, it's a book. The movie was quite good, but the book is even better. And again, Project Hail Mary, his second book, is also very thoughtful and very human. But not to spoil the plot, because you find out pretty quickly what's going on. It involves an American who ends up getting sent to another star to solve a problem with, and basically a microbial attack on our sun, which this star seems to have avoided. So they're going to study why this star is not getting dimmer like the Earth is, or like the sun is. Anyway, the setup is fine. I'll let the astronomers argue about its plausibility. But you can read from the dust jacket that he meets an alien in the process of trying to solve this puzzle. And Weir has really done a great job creating a very different kind of alien life.
Yeah,
it's sort of a spiderish looking creature with multiple legs, but highly manipulative. It's got like six legs, and it's an incredible engineer. It's really good at building stuff. Communication is totally different. These creatures communicate through sound. And it takes, I forget what the character's name is, so much for that. Bob, we'll call him Bob, the human who's out there, trying to solve these problems. Bob figures out eventually that the alien is communicating through sound. And has no visual sense whatsoever. And he finds it very difficult to explain to the alien. Once they figure out how to communicate, they manage to communicate by sound, and Bob on his spaceship has a way of sort of translating the alien sounds into something that he can understand, and vice versa. Anyway, it's very cleverly set up, which is what he does in his books.
Oh, good. Well, I will put it on my list.
Yeah. Check it out. But it's really fascinating to imagine an extraterrestrial creature that is so different from us.
Right.
And the fact that they call him Rocky because it's more of a mineral kind of biology, as it were, than a squishy Earthlings. But Rocky, the alien, cannot imagine what vision would be like. He thinks this is the most incredible, amazing development, which we just take for granted. I mean, that's the way vertebrates certainly, and most other forms of life on our planet work. Even single-celled organisms are phototropic, right?
Right.
Anyway, it goes on and on. Jay, why don't you give us a question, and we'll see what other people are wondering about.
All right.
Scott S. wants to know, wouldn't the comet be affected by high flux cosmic rays well outside the heliopause? Once inside, the cosmic ray effects would diminish to our typical comet state?
Yeah, absolutely. But the heliopause is this tiny thing. Voyager is outside it now. It's 120 astronomical units. That is 120, 110 times the distance of the
just for beginners, why don't you just give us a 1 or 2 sentence definition of the heliopause?
So the heliopause is that region, the boundary where ions and particles from the sun cease to dominate our local environment and the interstellar medium. That is the gases between the stars become just as important. Okay. So the heliopause is sort of our solar dominated bubble, and it's only roughly 100 times the Earth sun distance. So that's tiny compared to the vast distances, the light years of interstellar space. So most of the most of the cosmic ray effect would be while the thing was in interstellar space. And yeah, even if it's been shielded while it's in our solar system, who cares? That's only a minor fraction of the total time.
All right. Do we have another question? Here we go. Jay wants to know, given that huge numbers times I don't know equals I don't know, isn't the skeptical stance to say I don't know? That answer isn't satisfying, but promotes science and the search to find better answers.
Well, I think I did say I don't know, but I also expressed my own opinions based on what I think are reasonably good arguments. The 100 billion species, the fact that we appeared very late, the fact that we can destroy ourselves, and the fact that we haven't, in a clear way, seen the aliens. And so I think we do know pretty clearly that it's not going to be 10 billion communicating species in our galaxy at a given time. So, and I think it's much less than that. But yes, I admitted we don't know, but we can still try to search to find better answers. So if I were to say, if you want to decrease the range of the Drake equation, don't spend your time studying the star formation rate of our galaxy. Rather, spend your time on the biological and sociological and other such factors, because they have a much, much bigger uncertainty. And so that's a useful thing. That is, the astronomical uncertainties no longer dominate. It's biology and the appearance of life, and how likely is it to become intelligent, and then how likely is it to become communicative, and things like that. And so it's out of the domain of the astrophysicists now.
Yeah, that's why they invented astrobiology, right?
There you go. That's right.
So, am I being incredibly naive? Whenever I've thought about extraterrestrial and the UFO people, and we're being visited by aliens and abduction by aliens and all of that, I've always thought, well, yeah, given we got buckets of galaxies out there, and now we know that planets aren't rare, so we got buckets of planets around galaxies, and just by sheer numbers, there's bound to be something out there. But the fact that something is out there doesn't necessarily mean that they'd find us, because this is a needle in a haystack situation. The universe is a hell of a haystack, right. And we're just the head of a pin, as we're not even a whole needle. And the likelihood that aliens would actually discover our little planet, especially given the huge amounts of the billions of years that the universe has been around, in that little window when we would be aware of them, as you pointed out, is just vanishingly small.
Right.
Does that make any sense? Or
yeah, it makes a lot of sense.
At least in terms of visitation by others.
Except for the following argument, one can show that if you send machines, computers and robots and stuff that just they don't care how slow the spacecraft are going, but they land on planets elsewhere, and then they duplicate themselves, and they send out other probes and stuff. You can basically populate a galaxy pretty easily in 100 million years, or certainly by 1 billion years. Okay. And given that the chemical evolution of the universe was such, and of our galaxy was such, that Earth-like planets could have formed billions of years before our Earth did 4.5 billion years ago. If even one such civilization reached the stage where they could and desired to colonize the galaxy, they could easily do it at non-relativistic speeds, just at the escape velocity from their home planet and stuff. You just propagate out. And in fact, Robin Hansen's latest work, he's working on a book with which I don't as much agree as with his great filter. He's basically saying that the fact that we haven't seen them out there means that they're expanding outward at like 1/3 of the speed of light. Because, if they were expanding at the speed of light, then you don't see the phenomenon until it hits you, right? Because it's not at all, the light isn't at all ahead of it. So he says the fact that we haven't seen them means that this civilization, and there are others in other galaxies, they're expanding at 1/3 of the speed of light, and soon they're going to fill up our whole galaxy and the whole universe. So there I disagree with him. But my point is simply that you don't need speeds of a third of the speed of light, just very slow speeds, but enough time will allow you to populate a galaxy. And so if a civilization wanted to do that and they see a nice looking planet, then you might say, well, wow, were they that altruistic that they decided to let us just, we're little ants, let us develop, and they'll go and populate some planets that don't have their own indigenous independent life.
Well, and in the comment section, in the private chat, Jay is getting on my case for giving away the plot of Project Hail Mary. Gentle viewers, I'm not. There's so much more in this book. But that said,
so here's a
thing. Let's do the question instead.
Yeah.
Do you think it's possible that intelligent life could be sending out signals using a type of energy source we've not yet detected, akin to dark matter, dark energy?
Yeah, that's certainly possible. You know, we don't know what we don't know, and we should keep our minds open to things of this sort. Oops, sorry about that. Let me just stand up. And well, it's my energy efficient office, right?
That's right.
It's a motion detector, and so I need.
But you're moving. But you're moving
around my. I think that's why it's not happening more often. But anyway, we you know, when I was a student, dark matter and dark energy did not exist. I mean, Vera Rubin's work in the 1970s was just beginning to gain some attention, but not really until the 1980s. And, you know, Fritz Zwicky proposed dark matter in the 1930s. And dark energy, well, you know, I was on two teams that discovered the accelerating expansion of the universe, driven, we think, by dark energy. But that wasn't a piece of the puzzle or the pie, the cosmic pie, until 1998 or 99, right? So we should certainly be open to the possibility of different types of energy out there that they out there could be using to communicate. But it would have to be a type of energy that is not having any noticeable effect on stuff here on Earth, because we understand things here on Earth pretty well. I mean, we don't know how life formed and all that, but you know, we understand how transistors work, and you know, we build rockets and we build automobiles and computers and all that. So it can't be an energy that's screwing up a lot of things that are happening here on Earth, right? Because we don't see evidence of things being screwed up. But it might be some kind of energy that we haven't detected and that doesn't really interact with coffee cups and spoons and things like that. So sure, could be possible.
You don't know what you don't know. Kevin Reardon says, so how long does it take for intelligence to come about after the star ignites?
Well, that's the big thing, right?
We have an N of 1.
Yeah, we on Earth, it took really a long time. That's part of my point. That if it's if our example is common, then this is a rare evolutionary outcome that takes a long time. And it's possible even that, as I said, though I agree with and understand the general argument that simple life formed on Earth about as quickly as it could have, nevertheless, if there's a distribution of formation times, and let's say the more typical one is 10 billion years, even for microbes. Well, our sun doesn't, it only lasts on the main sequence. That is as a fairly normal luminosity star that's not changing much for 10 billion years. And so if typical stars take 10 billion years to even develop microbes, and then it takes another 4 billion years for intelligence, then they're not out there. Or conversely, if microbes occur really quite quickly, but at 4 billion years, we were on the short end of the distribution for the development of intelligent life, right? That's possible too. It's also possible we were at the long end of the distribution and we were just unlucky. But in that case, they're out there all over the place. And for other reasons that I articulated, I don't think they're out there all over the place.
Where are they? In other words.
Yeah, right.
Yeah. All right. David Allman Smith wants to know, why would a technologically civilization?
Yeah, technologically
civilized civilization choose to embark on an explosion of stellar colonization?
Right. So I said they might not. They might choose that, you know, to realize their real estate is limited, and once they use up all the stars in the galaxy, then it's really a long way to the next galaxy, and it's not impossible, but it'll take a really long time. So maybe that's the way in which they're really more intelligent than we are. They decide to spread their seeds to a few places so that if the errant comet comes in and destroys one planet or life on one planet, then at least it won't have destroyed it elsewhere, right? Elon Musk makes this argument for Mars and stuff. Not that we should not take care of Earth, but just put our seeds in a bunch of baskets,
Sure.
But don't colonize the whole galaxy. But certainly the trend of humans on Earth has been to colonize as much of Earth as possible.
Yep.
So it's not entirely ridiculous to think that at least some of them, and it only takes one, right? What if there's 1,999,999 of them decide not to colonize, but one decides to colonize? That's all it takes if they're successful, right? And they will rule the world. They will rule the galaxy. That could be a pretty powerful incentive for the right type of alien.
Indeed. Okay, our last question. How do you feel about scientists or skeptics who discuss alien life as being inevitable?
Yeah, I think it's not inevitable because of the numbers I showed. And if you restrict yourself to our own observable universe, I came up with 1 in a trillion galaxies. That was pretty pessimistic, but not the most pessimistic. So it could even be that beyond our observable universe, it doesn't happen. If the universe is infinite, I think life of some sort is inevitable, because I believe it's a natural as opposed to a supernatural process. And so it could be very, very rare that you get these molecules coming together in the right way and reproducing and evolving and all that. But if the universe is infinite, and we do not know that it is, then I think it's inevitable for some sort of life. But our observable universe, which is what people often mean by the universe, they really mean the observable universe. I agree that it might not be inevitable. We might be the only ones, at least that are intelligent. Less probable we're the only ones even among the microbes and stuff. There, I'll grant the people that say that it's a lot easier to form bacteria and microbes. But even that is not entirely inevitable in a space of 10 to the 12 galaxies with 10 to the 11 stars per typical galaxy. Those are big numbers, but if the probability is the inverse of an even bigger number, then the product is 1 or less. So, yep.
Lots to think about.
Yeah.
All right. I'm going to thank you profusely and profoundly for spending this hour with us. Viewers, hang in there, because I've got some very important things to say after I thank Alex for all of his assistance with us and informing us of all these various and interesting things. So I hope maybe you'll come back to see us some other time and talk about some of your other interesting ideas and your other work. But thanks so much for spending tonight with us.
Pleasure. Thank you for the invitation.
All right, my friends, I do want you to come and join us next month, where on the second Thursday of June, which is June 8th, the next SkepTalk will be given by Mark Abrahams. Now, you may recognize this name. Mark Abrahams is the editor and a major writer of the Annals of Improbable Research, or AIR, and he is the host and inventor of the Ig Nobel Prizes. So you can imagine that this is going to be a pretty amusing program. This is a good way to start the summer. Starting the summer with a laugh, maybe early and often, good thing for us all. Also, there's one more announcement that I want to make that I want to call your attention to, and this is a new program that Bay Area Skeptics is beginning. This is going to be an in-person program for the first time in 3 years. We're actually going to be meeting in person. It's very exciting. We're going to call this new series Hanging Out With, and we will meet in person with an interesting skeptic for conversation and well, hanging out. Our very first program will be with the Wikipediatrician herself, Susan Gerbic, who will conduct a workshop on getting people out of rabbit holes. Now, you may have met Susan at SkepTalk, one of our earlier meetings, or read her articles in Skeptical Inquirer, or read about her stings of grief vampires, people who prey upon the wishes of the bereaved to be in touch with their deceased loved ones, demonstrating hot and cold reading and doing some extremely interesting work. Susan makes a lot of contributions to the skeptical community. I think that you will enjoy hanging out with her on Sunday, May 20th at 1 o'clock in the afternoon in person at the Berkeley Public Library, the downtown Berkeley Public Library. It's very close to BART, so it's really easy to get there. Please join us. Join us on the 20th for hanging out with Susan Gerbic, and join us next month on the 8th with Mark Abrahams, who will tell us about and tickle us with the Ig Nobels. Thank you again, Alex, for joining us tonight, and thank you for watching. And please come back next month and see you on the 20th as well. Good night.